So this instrument here is our helium leak detector. It's part of our CCIT offerings, or container closure integrity test offerings. Helium leak detection is one of the most versatile tools for container closure integrity testing that we have here at our facility at CS Analytical. The reason being, helium, it's super small, it's non-reactive, and so it's a fantastic gas for making its way through different leak paths. This instrument here is a helium leak detector. And so what this instrument does is it's quantifying how much helium is being pulled into that system and reporting that as a leak rate. Essentially, this is just a fancy mass spectrometer that's tuned specifically to look for helium coming out of this package. So helium leak testing, it's often used for inherent integrity evaluation under USP 1207. Because it is super sensitive, it's a fantastic tool for demonstrating, first of all, that your components, when they are put together, create an integral package. Also a fantastic tool to incorporate, as I mentioned previously, with capping optimization and residual seal force to evaluate when I apply these closures at different forces and I measure helium leak rate, do I find a certain application force that gives me very low leak rate results? So it's a really useful tool for package and process development, validation, and almost always we incorporate helium along with some other test methods at a future life cycle stage as part of an overall strategy for container closure integrity, looking at the empty assembled components with helium before looking at filled finished product package systems, let's say on stability by another method. Helium leak detection, I mentioned it's very versatile, and all it is a vacuum system with a mass spec. This here is our fixture, and this enables us to swap out different designs to test different types of package systems. This fixture here is for pre-filled syringes, and you can see here that I have a pre-filled syringe with the needle shield down in that area. And what I'm able to do is tighten that into the fixture, start a test. This here is a flow needle that is connected to a flow meter, ultimately connected to 100% helium. So what I'm able to do is place my sample in the fixture, start that vacuum. And so what's happening as I start that vacuum is that I have an atmosphere here, and on the other side of the seal that we're interested in testing, that RNS, or rigid needle shield, we're pulling almost absolute vacuum. So we're sucking vacuum on that closure region of interest. I'm able to set my flow meter to a certain flow rate of helium that we determined during our protocol design step, insert my helium flow needle into that package of interest, open up the valve to start the flow of helium, and I observe my leak rate response on the instrument here to see, do I see a spike in my reading as a result of helium making it from the inside of that container through the closure and into the system.